Hello, welcome to the Dreamy Physicist, where science whispers and sleep listens. Here, we slow down, float gently through the fabric of reality, and explore the strange beauty of the universe, one dreamy thought at a time. This is not the science of numbers and noise, but of wonder, silence, and soft curiosity. Particles pass through walls. Stars are born in impossible places, and even your breath carries quantum secrets. So lie back, close your eyes, let your mind become still as we journey into the quiet edges of physics together. The night is quiet now. The world outside your window fades into darkness. Its shapes and edges soften by the hush of sleep. You lie still beneath the weight of blankets and silence. And slowly, the air around you thickens with mystery. Your thoughts, once sharp, begin to blur. The ticking clock seems farther away. Even the outline of your body feels like it's dissolving, as if you're drifting just slightly beyond yourself. This is the edge of waking, where the ordinary rules lose their grip, where time becomes syrupy and the mind becomes curious. And here, just here, something begins to stir. You may not notice it yet, but your body is already humming with impossible things. Tiny particles dance within you, not like marbles in a box, but like songs in the air, everywhere and nowhere, all at once. You are not a solid thing. You are built of empty spaces, atoms stacked like stars, with vast distances between their tiny cores and flickering clouds. Your hands, your breath, your very skin, they only feel solid. But in truth, they are made of whispers. The deeper you look, the softer the world becomes, like trying to hold fog in your palm, like chasing a shadow that keeps shifting. This softness is not weakness. It is the fabric of reality. Physicists once believed the world was made of hard things. Solid stones, steady clocks, predictable paths. But then, as if waking from a dream, they peered closer and the world began to dissolve. What they found was a universe not carved in stone, but painted in probability, a realm where things are never fully here or fully there, where being somewhere is a suggestion, not a guarantee. At this edge of reality, the rules change. Particles, the smallest pieces of everything you know, don't move like pebbles skipping across water. They move like ripples, like echoes, like thoughts drifting across a sleepy mind. Their position is never fixed, only guessed. You can't say exactly where something is, only where it might be. This is not fiction. This is not imagination. This is how the universe works. Beneath the skin of what we see, you lie there, listening. And though your eyes are closed, you are seeing deeper than before. The soft edge of reality is all around you, not just in the night, but in your breath, in your bones, in the stillness between heartbeats. Your body is not just following the rules of biology, it is obeying the secrets of quantum physics. Tiny particles, flitting and fading, forces that bind and repel, unseen and unbroken, wave functions, pulsing softly like lullabies. Imagine a sheet of silk, stretched out, trembling gently. This is how reality feels beneath the surface. Not rigid, but alive with motion. every possibility dancing on that trembling field. And from this field, you emerge. Not just you, but stars, light, gravity, time. All born from the same invisible sea. All bound by rules that defy our everyday sense of what's real. Here at the edge, you are reminded that what seems still is never truly still. Even your quietest breath is filled with quantum breathwork, uncertainty, motion, energy. It's a kind of music, one you can't hear with your ears, but feel if you listen deeply enough. Everything is softer than it seems, more fluid, more mysterious. You are not a fixed shape, but a flickering presence. Close your eyes a little more. Let the softness deepen. Imagine you are sinking, not into your bed, but into the very fabric of existence. You fall gently between the threads of space and time, where particles no longer behave as they should, and the world becomes a dream of probabilities. It may feel strange, but you belong here. This softness is your origin. You are made of atoms that once belonged to stars. You are stitched together by the same quantum field that pulses in the heart of galaxies. And yet, you are here, now, listening. Reality has softened enough to let you glimpse what lies beneath. The stillness isn't empty. It's full of things waiting to be noticed. Tiny truths, hidden in the hush. You are at the boundary now, between what feels real and what truly is. And on the other side of this boundary, just beyond the veil of sleep, a question begins to form. What truly is a particle? Is it a speck of matter? A point in space? Or is it something stranger, more like a ghost of possibility? The softness deepens, and the question stays with you, pulling you forward, inviting you to discover. The question hovers gently in your thoughts. What is a particle, really? You've heard the word so many times. In classrooms, in science books, maybe even whispered in documentaries late at night. It sounds simple, even small. But tonight, as you lie still, letting your mind drift beyond the surface, you begin to feel how mysterious that word truly is. You are made of particles, billions upon billions, building your bones, your breath, your blinking eyes. But what are they? Are they dots? Little balls? Tiny specks of matter bouncing around inside you? That's how we often imagine them. Tiny marbles clacking into each other, like cosmic billiard balls. But that picture, while tidy and familiar, isn't quite true. It's too sharp, too certain. Reality, especially at the smallest scales, is much more delicate. Let yourself soften. Let your imagination widen, like a ripple in still water. Imagine a firefly in the dark, a brief pulse of light, here and then gone. Now imagine that firefly isn't just in one place, but glowing in many places at once, flickering like a thought, stretched across space. That's closer to what a particle truly is. Not a dot, but a probability, a possibility, a wave of maybe. You see, in the world of the very small, the quantum world, a particle doesn't exist in just one place until something or someone observes it. Until then, it might be here, could be there, and in some deep, beautiful sense, is everywhere in between. This shimmering uncertainty is called a wave function. It's like a map made of maybes. Each point on that map tells you how likely it is to find the particle there if you go looking. But until you look, it's not that the particle is hiding. It's that it isn't anywhere in particular. It's spread out, not smeared, not lost, but gently present across many possibilities. You lie still and let this idea wash over you, that the smallest building blocks of you are not fixed things. They are not there or here until they are asked to be. They are asked by interaction, by attention, by touch, or light, or measurement. It's as if the universe waits to be noticed before it chooses a shape. That's the world of the particle. Not just matter, but potential. The word particle is used for convenience. But in truth, most particles are also waves. Not waves like ocean swells, but waves of probability, of presence and energy, rippling quietly through space and time. This is what light is. This is what electrons are. Even atoms, even you, carry this dual identity. You're a particle and wave. You are presence and possibility. Imagine a single electron spinning slowly in the darkness, not turning like a planet, but possessing a kind of intrinsic twist, a property called spin. But even spin is not what it sounds like. It's not rotation in space, but a quality, a flavor of being. Particles don't behave the way large things do. They are not bound by the rules you see around you. They slip through walls, appear where they shouldn't, entangle across vast distances. You'll get to that in time. But tonight, let's stay here with this quiet, rippling presence. A particle can interfere with itself. Yes, not with another, but with itself. Like light passing through two slits, creating a pattern of brightness and shadow that no single point of matter should make, unless that point is also a wave, unless it carries with it all the paths it could have taken until one is chosen. You are not dreaming. You are simply beginning to understand that reality is stranger, softer, and more wondrous than you were told. You may be lying in one place, but the particles in your body, in your blood, in your brain, are always on the edge of change. They buzz not with noise, but with potential. Single electron can tunnel through a barrier it has no energy to climb, not because it breaks the rules, but because it is the rules, rewritten at a scale too small to see. A particle is not a thing. It is a question, a whisper, a vibration of possibility in a universe that seems to dream of itself. And when many particles gather together, they create everything you know. Rocks, trees, stars, time. It's hard to hold onto this idea. It slips away, like a shadow in the corner of your eye. But let that be okay. Let it drift. Let it settle. Because the beauty of this mystery is not in solving it, but in living it. The world of particles is not hidden from you. It is you. It is everything you touch, every word you hear, every breath you take. It is the gentle hum beneath your existence. It is the source of your stillness and your motion, your forgetting and your remembering. Now you lie there and feel the quiet within your bones. Not empty, but full of flickering life. Not hard, but woven of waves. The more you learn, the more the old images fade. The tiny marbles, the bouncing balls, the tidy diagrams, they give way to something else, something more like poetry. A particle is not a fixed dot, but a blur with a heartbeat, a whisper in the field of everything, a traveler across paths not yet chosen. You are made of these, and they are made of something even stranger. But for now, you drift among them, the gentle companions inside you, carrying the memory of light and the promise of change. And as you float deeper into sleep, one thought lingers in the stillness. If particles are not solid things, then what does it mean to say something is somewhere? What does it mean to know where you are when even your atoms are undecided? The wave deepens, the night quiets, and somewhere inside that hush, a new question begins to glow. The night deepens. Your breath is slow now, settled like mist over still water, and the world around you continues to blur, not in confusion, but in quiet invitation. You are no longer seeking sharp answers. You are ready to feel the beauty of not knowing. Because here, in the soft spaces between certainty and sleep, uncertainty is not a flaw. It is the fabric of everything. You are wrapped now in a strange, invisible quilt, a blanket not made of cotton or wool, but of uncertainty. It hums beneath your ribs. It weaves itself between your thoughts. And it has a name. Heisenberg's uncertainty principle. It is not a warning. It is not a gap in our knowledge. It is a truth, soft but unshakable, about the nature of reality itself. Imagine, for a moment, you are holding a single particle. Let's say an electron, small and shy. You want to know two things: where it is and how fast it's moving. Seems simple. Seems like the kind of thing you could measure if only you had the right tools, the right microscope, the right timing. But as you look closer, the truth slips through your fingers. Because the moment you try to pin down the electron's location, to say, here it is, yeah, its motion becomes more uncertain. The sharper the place, the fuzzier the speed. And if you instead try to measure its momentum, how fast and in what direction it's moving, then its position begins to blur, like breath on a cold window. This isn't a matter of instruments being clumsy. It's not about better cameras or faster sensors. It's deeper than that. It's written into the mathematics of the universe. At the quantum level, you cannot know both where something is and how it moves at the same time with perfect precision. This is the uncertainty principle. It's not just a limitation, it's a structure, a rhythm, a heartbeat behind the motion of particles. You might imagine it like trying to find a butterfly in the dark. You shine a light to see it, but the light itself disturbs its wings. The act of seeing changes what's being seen. Or better yet, picture a wave gently rolling through a quiet pond. You can tell where the wave is roughly, but it's spread out, never sitting still. To know its precise shape, you must give up knowing its exact place. A particle, like a wave, does not belong to a single dot in space. It exists across possibilities. Its being is smeared like moonlight on water, and the universe honors this uncertainty. It's not chaos. It's grace. You are surrounded by it, made of it. Even your thoughts obey it. The neurons in your brain, their signals, their chemistry, their tiny, ticking motions, are built on uncertain particles dancing through probable paths. And yet, here you are, thinking, feeling, being. You don't need perfect precision to exist. In fact, you only exist because of the blur. If the universe were perfectly rigid, if every particle sat still and certain, then nothing would flow, nothing would move, no life, no breath, no warmth. It is this softness, this shimmering maybe, that gives rise to change, to transformation, to music, to time. The uncertainty principle is not a prison. It is a permission. It allows the world to breathe. Because of uncertainty, an electron can tunnel through barriers. Because of uncertainty, stars can fuse atoms in their hearts. Because of uncertainty, matter doesn't collapse into stillness. It is the uncertainty that makes everything possible. And so, as you lie beneath your blankets, feel the quantum 1-2. It doesn't hold you tight. It cradles you in possibility. You're never perfectly still. You are never fully known. And that is the secret. That is the magic. There is comfort in knowing that even at the smallest scales, nothing is locked in place. Everything is always becoming. Your life, your body, your memories. They all float on this sea of uncertainty, like boats on shifting tides, steady not in their fixity, but in their motion. You may think of this as fragile, but it is, in truth, strong, to bend without breaking, to move without being lost, to exist as both wave and presence. The uncertainty principle is not a defect in nature. It is nature, and the more you welcome it, the more deeply you can rest. You don't need all the answers to fall asleep. You don't need to solve the riddle. You only need to trust that the softness beneath you is holding you in place, even as it drifts. You float now in the field of not knowing, and it feels warm. Perhaps for the first time, you understand that precision is not peace. Certainty is not calm. Uncertainty is the breath between notes, the hush before the wave, the quiet between questions, the place where sleep begins. Now, in this quiet pocket of not knowing, you realize something simple. To be uncertain is to be alive. To rest in uncertainty is to be part of the great unfolding. And as the chapter of this night continues to turn, your mind finds one last thought to cradle. If a particle can never fully settle into a place, can it pass through barriers without ever quite touching them? What if the world, too, lets us slip past the impossible, not by force, but by softness? There is a wall. It rises quietly in front of you now, not of stone or steel, but something deeper, a barrier of certainty, of resistance, of you shall not pass. You stand before it, or maybe drift, and for a moment, you feel its weight, even though you can't see it. It's not solid in the usual way. It's made of energy, of opposition, of all the reasons something shouldn't happen. You've seen walls before, in life, in thought, in dreams. But this one is different. It is not built to keep out people. It is built silently to block particles, to stop the very building blocks of the universe from slipping past. In the classical world, the world of everyday things, a wall is final. If you do not have enough energy to climb it, you bounce back. If your engine cannot overcome the hill, you roll back down. Rules. Rigid. Predictable. A ball thrown at a wall either breaks or is stopped. It does not pass through. And yet, in the world beneath the world, in the soft humming place where particles dwell, a new kind of story unfolds. Here, at the boundary, the impossible begins. Imagine a small particle, say, an electron, approaching a barrier. This barrier is taller than its energy, like a mountain it can't climb. It doesn't have enough push, enough drive, enough permission. Classical physics tells us the outcome. It should bounce. It should reflect, go back the way it came. But quantum mechanics whispers otherwise. In this quiet realm, where waves and probabilities replace paths and rules, the particle doesn't always obey the wall. It hesitates. Its wave function, the soft cloud of possibility that describes where it might be, doesn't stop cold at the barrier. It spills into it. Not deeply, just a little. A fading echo, an exponential sigh that stretches into the forbidden zone. And here's where the miracle happens. Sometimes, against all classical sense, that tiny echo emerges on the other side. The particle, which lacked the energy to climb, appears beyond the wall, as if it never touched the barrier, as if it slipped through it. This is called quantum tunneling. It is not a trick, not an illusion. It is real, measured, reliable, and it happens all the time. Right now, even as you lie still, your body depends on it. The sun shines because of it. Life exists because particles sometimes refuse to stay on their side of the wall. It's important to say this clearly. The particle does not break the wall. It does not dig under it. It does not explode over it. It simply fades through. Its probability of being somewhere never quite drops to zero, not even inside a barrier. And if the wall is thin enough, if the odds are just barely tilted, the universe allows the particle to tunnel through. You might think of it like a shadow that bleeds across a curtain, or a sound that echoes faintly through a sealed room, or even like a dream that slips into your waking mind without knocking. This is the grace of quantum tunneling. It defies common sense, but not the deeper sense, because at the quantum level, existence is not a yes or no. It is a maybe, a delicate balance of possible and impossible. Even barriers, those firm declarations of no further, are, in this space, just suggestions. And that changes everything. It means the universe is not locked down. It is porous, breathable, more like mist than marble. Even the things that say you cannot pass sometimes whisper, but maybe if you're quiet enough, you can. And if you pause here, beside this strange wall, you can feel the resonance of that truth in your own life. How many barriers have you seen? How many limits have been drawn around you? Not enough time, not enough energy, not enough strength, too much fear. And yet, somewhere deep inside, you felt the quiet truth of tunneling, the feeling of slipping past something you didn't think you could, of moving not with force, but with faith. with stillness, with presence. That, too, is tunneling, and as above, so below. What particles do, you do also. This chapter of quantum truth teaches us something tender, that barriers are not always ends, that even in the presence of resistance, there remains a path, not forward in the usual sense, but through. The wall that should not be crossed is crossed every moment by particles too small to see, but too real to deny. And in that crossing, they change the world. Without tunneling, the sun could not shine. Without tunneling, protons in stars would never meet. Without tunneling, life's delicate chemistry would freeze into stillness. And so, this act of silent passing, this refusal to be denied by a wall, is not just strange, it is sacred. It reminds you that the universe is not only governed by power, but by possibility. Not everything needs force to move. Sometimes, just being is enough. And now, as your thoughts drift further inward and your breath falls deeper into rhythm, you are left with a quiet vision, a tiny particle, not strong, not loud, but patient, arriving at the wall, pausing, not breaking, but slipping, and now is free. How does this happen? How can something pass through a barrier without crossing it in any ordinary sense? The answer lies not in motion, but in probability. The particle becomes not just a point, but a cloud, a shimmering blur that bleeds across boundaries. And it makes you wonder, doesn't it? If probability can bring a particle to the other side of a wall, then where, truly, is the particle before it is seen? Where does it live? In the silence between one side and the next? And so, as the wall fades behind you and your awareness softens into something dreamlike, a new thought begins to form, as soft as mist, as light as breath. If a particle doesn't move by pushing, but by being likely, then what, really, is a probability? Not every journey is made in footsteps. Not every arrival comes from moving forward. Tonight, you follow the particle again, the small one, the quiet one, the one that stood before the barrier and refused to obey the rules, not by force, not with protest, but with a softer kind of defiance, the kind that simply continues to be, even where it shouldn't. You are not watching it as you would a runner in a race. There's no path to trace, no arc in the air, no visible motion. It is there, and then it is elsewhere. Still the same particle, but now on the other side of the wall. And it did not climb. It did not burrow. It did not crash or push or break. It tunneled. But tunneling, you begin to realize, is not a movement in the traditional sense. It is not pushing past. It is slipping beneath. A dance beneath the barrier. So subtle, so strange, that even calling it a path feels too definite. So how does it happen? You return to the wave, to the idea you've met before, that particles are not little balls, but shimmering waves of possibility. When a particle approaches a barrier, its wave doesn't stop abruptly. It spills over. It enters the forbidden zone, fading as it goes. Like music heard through thick walls, the wave becomes small, but it doesn't vanish. And if the barrier is thin enough, that wave continues on the other side, growing once more, as if the particle had been waiting there all along. From the outside, it looks like the particle just appears. But beneath that moment is a deeper process, one not of movement, but of presence. The particle exists as a probability cloud, a wave function that gently leaks into regions that should be off limits. That leak is the tunneling, not a forceful crossing, but a quiet persistence of possibility in places that forbid it. You picture it now, a waltz in the dark, where the dancer moves not by stepping, but by expanding, by allowing the music to carry them into places even silence doesn't expect. This is not magic. It is not even mystery, not in the scientific sense. It is math, measured, predictable, repeatable. But it still feels like magic, because in the world you're used to, barriers are final. Walls mean no. End of story. Yet here, beneath the surface, in this delicate world of quantum behavior, barriers are only suggestions. They are respected, but not always obeyed. Tunneling happens all the time. Right now, in your own body, protons and electrons are slipping through energy barriers. Your cells rely on it. Your enzymes depend on it. The molecules of life are built on the ability to cross boundaries without ever seeming to do so. Even the sun, the star that warms your skin and guides your clock, could not shine without tunneling. Its core is not hot enough, by classical standards, to overcome the forces between protons. They shouldn't collide. They shouldn't fuse. And yet they do. Not often, not easily, but enough. Enough to light the sky. Enough to grow the trees. Enough to make life possible. All because, every so often, a proton doesn't follow the classical rules. It tunnels. It dances beneath the barrier. You let this settle in your chest for a moment, that even the light of day is born from the quiet persistence of particles moving through the impossible. And now, a thought begins to take shape. Could tunneling be more than just physics? Could it be a metaphor for something in you? Think of the times you've faced a wall, not a physical one, but an inner one, a fear, a memory, a hesitation, a place you told yourself you couldn't pass. And yet, somehow, you did. Not all at once, not in some grand leap, but gently, unseen. You woke up one day and found yourself on the other side. That, too, is a kind of tunneling. You didn't overpower the wall. You moved through it by becoming more than one point, by allowing yourself to exist in the realm of possibility. Particles do not tunnel by will. They do not choose. But you carry choice, awareness. You can sense the wall, and you can soften toward it. Tunneling, then, becomes a reminder that not everything is overcome by strength, that some things are passed by patience, by presence, by the natural drift of what is meant to move. Even in quantum physics, tunneling depends on time, on thinness, on chance. Not every particle tunnels. Most reflect. Most bounce back. But some, just a few, find themselves elsewhere. The mathematics tells us how often. It gives us the probabilities, the decay rates, the distance a wave function can stretch before fading into silence. But you don't need numbers to understand the feeling. You only need to remember what it means to face something that tells you no and find yourself slowly, gently on the other side. The dance beneath the barrier is not wild or chaotic. It is slow, precise, elegant. Um, Breath. A ripple in a field that never truly rests. Particles are not rebels. They are listeners. They respond to the rules, not with defiance, but with deeper knowledge. They know that even barriers breathe. And now, as your mind begins to quiet, you sense that truth as well. Not everything is as closed as it seems. Some things, some problems, some fears only need you to soften, to pass through. You let that idea cradle you like the soft edge of a dream. You lie still, but your thoughts expand, not in distance, but in awareness. You are the wave function, spread wide, touching even the places you thought unreachable. And as you drift further inward, deeper into rest, you find one last image to hold. A barrier stands, quiet, cold, unmoved, and yet, without sound, a ripple appears on its far side. A presence, a particle, you. And now the question comes, as gentle as fog settling on still ground. If particles tunnel, if they exist beyond where they are expected, then what is the shape of the space they move through? What is the field that allows such passage? What is it that truly surrounds us? You are still, but around you, the world is not. Not in the way you once believed. In the stillness of your room, your breath soft and steady, you begin to sense it, the gentle shifting beneath what seems solid. It isn't noise, it isn't chaos, it's deeper than that, slower, like the rise and fall of waves on a shore you cannot see. This is the ocean of probabilities. It surrounds everything. It is everything, not made of matter, but of meaning, possibility, the quiet mathematics of maybe. You have met its edge before. When the particle danced beneath the barrier, it didn't choose a single path. It didn't declare, I will go here and no farther. Instead, it rippled, it spread, it explored all it could be, a cloud of potential before collapsing into certainty. Now you float deeper into that cloud, into the vastness of what might happen. Probability, the word that feels cold in textbooks. But here, in this moment, it is warm, soft, alive. You are not in a world of yes or no. You are in a world of maybes. And this ocean moves not with randomness, but with rhythm, patterns so subtle they feel like breath. Imagine dropping a pebble into a pond. The ripples stretch outward in all directions. This is what a particle does too. It doesn't exist in one place, but in all the places it might be. Until, at last, you look, you ask the question, and the wave becomes a point. Observation collapses the sea into a single droplet. That moment where possibility becomes reality is called wave function collapse. And yet, even that collapse is only part of the story, because before the drop, there was the ocean. And the ocean holds every future, every path, every outcome, nested within the present. You, too, are part of this sea. Your thoughts ripple across it. Your choices, your presence, shape the probabilities around you. It is not control, but it is connection. You are not drifting in a world that happens to you. You are part of the unfolding, and the unfolding is gentle. Quantum physics does not speak in certainties, but in likelihoods, in elegant equations that, with probabilities. It does not say, this will happen. It says, there is a chance, and in that chance, a universe is born. You remember now the double slit experiment, that soft, strange puzzle where particles behave like waves until watched, where observation shapes outcome. The pattern of possibilities collapses the moment attention is given. The act of looking, of measuring, of asking writes reality into being. Before that, it is only potential, a haze of could be. And so you begin to wonder, what if all of life is like this? Not fixed, not fated, but fluid. A set of probabilities that respond to attention. The particle does not know where it is until the question is asked. And perhaps, in some quiet way, neither do you. Perhaps your future, too, ripples with uncertainty, not in fear, but in freedom. Not everything must be known. Not everything must be predicted. Some things are more beautiful as possibilities, and the universe seems to agree. From the smallest scales, it builds using chance. Electrons don't orbit like moons. They flicker in clouds. Photons don't choose paths. They explore all of them until observed. And from those delicate fluctuations, stars are born. Galaxies spin. Life grows. From probabilities, certainty arises. But only just enough. Never too much. Always a little mystery. Always a sea beneath the surface. You float there now. Not with your body, but with your awareness. Let yourself drift. Imagine you are not one solid thing, but a shimmering pattern of probabilities. Each cell, each atom, each particle of you, existing in a web of outcomes. You are not one story. You are many, and the ocean holds them all. You may think of it as chaos, but there is structure here, a quiet architecture of possibility. The mathematics of quantum mechanics allows us to calculate the shape of these waves, to know how likely a particle is to be here or there, now or later. It is not random. It is not a dice roll. It is weighted possibility, a balance of outcomes, a cosmic choreography that responds not to will, but to awareness. And just like the wave function of an electron hints at where it may be, but never guarantees, so too do your choices shimmer with potential. You listen now to the hush around you. The clock has slowed. The air is thick with stillness. But within that stillness, the ocean moves, not with noise, but with meaning. Each heartbeat is a ripple, each breath a pulse, and every thought you allow to soften sends new waves outward into this probabilistic sea. It is tempting to wish for certainty, for solid answers, for fixed paths, but quantum physics gently reminds us certainty is an illusion. What we have instead is something softer, something more honest. We have possibility, and possibility is alive. Now, As your mind begins to settle, you feel the comfort in that. You don't need to know. You only need to float, to rest, to listen. The ocean does not rush. It does not demand. It holds. You are not lost in it. You are part of it. Your own wave function spreads gently outward, blending with the sea. You are not alone in the ocean. Every particle hums with the same rules. Every atom in your pillow, every molecule in your lungs, ripples with the same soft probabilities. Reality, then, is not a fixed place. It is a dynamic unfolding, a story that writes itself in real time. And beneath that story is the ocean. And in that ocean, you are free. And as you drift now, not into sleep, but into that liminal space where dreams begin, a final image glows in your mind. A wave, small, simple, spreading outward from a center you cannot see. It touches 1,000 paths. It hesitates. And then it chooses. Not because it must, but because the time is right. And so the question rises like a tide. If all reality ripples through this sea of potential, then what is it that finally tips the balance? What collapses the wave? What chooses the moment? You're still lying there, so calm now that even thought feels optional. The hush has deepened, not with silence, but with softness. And in that softness, you remember the particle that passed through the wall. It still echoes in your mind. The impossibility of it, the silent dance beneath the barrier, the quiet slip from one side to the other without ever being seen inside. You ask yourself, was that just a trick of math? Just a particle playing make-believe? But now, here in the still dark, you begin to feel it more deeply. This isn't just a curiosity of the quantum world. This is something that touches you directly, intimately, constantly. Tunneling is not a distant miracle. It's happening inside your body, right now, with every breath you take. You are not watching the quantum world from the outside. You are the quantum world, a living, breathing cloud of probability. And in your cells, tunneling is at work. Let's follow it, slowly. Let's turn inward. Your body is alive with tiny machines, enzymes, molecules, biological gears turning in impossible harmony. Many of these reactions rely on a simple miracle. A particle, like a proton or an electron, appears on the other side of a chemical barrier without ever climbing over it. It should be stuck, but it's not. It tunnels. In a process called quantum tunneling, your body cheats the classical rules. Not sometimes, not rarely, but constantly. Deep within your mitochondria, those powerhouses humming in your cells, tunneling helps move electrons from one molecule to another, fueling the spark of life. If electrons had to wait for enough energy to cross every barrier, you'd run out of power. Too slow, too inefficient. But quantum mechanics gives you a shortcut. Tunneling makes life efficient, fast, possible. You are here, in this moment, resting, breathing. Because of that elegant cheat, you may never feel it. You may never see it. But with every heartbeat, the laws of quantum physics bend, just slightly, so that life can continue. Tunneling doesn't break the rules. It shows you there are deeper rules, beneath the ones you think you know. In school, you learn that particles must climb over barriers, that to pass through, they must have enough energy. But in the quantum world, there's another option. They simply exist on the other side, not by force, by possibility. The wave function, that shimmering mathematical whisper describing where a particle might be, doesn't stop at walls. It stretches, it seeps through, and sometimes, not often, but often enough, the wave survives past the other side, and suddenly the particle is there. The moment is complete. The impossible becomes the actual. And just like that, a reaction inside your body continues. Spark flows. A breath is taken. It's not just biology. It's not just chemistry. It's tunneling. It matters to you because it is you. And even beyond your body, the story stretches. In the heart of stars, where protons must overcome powerful electric repulsion to fuse and release light, tunneling opens a path. The temperatures alone aren't enough to force the fusion, but tunneling lets protons pass through a wall they shouldn't cross, and the star lights up. Your star, the sun, tunneling lights every second. Without that soft quantum escape, there would be no sunshine, no warmth, no earth, no you. Tunneling matters because it makes light, because it makes breath, because it makes life. And yet, it is so gentle, so unassuming, a quiet yes in a world full of no. The more you reflect on it, the more poetic it becomes. A particle faced with a wall does not fight. It does not force its way through. It simply waits, expands, exists on both sides until one version fades and another becomes real. Isn't that a kind of hope? That even in the face of barriers, possibility still finds a path? That softness, that gentleness, can overcome what seems unmovable? Perhaps you have felt this in your own human way. The moment when something felt impossible, until, slowly, it wasn't. Not because the obstacle changed, but because you did. Because something in you stretched, quietly, invisibly, and found a way through. Tunneling doesn't teach us to break walls. It teaches us to listen for the quiet paths beneath them, to trust in the softness of nature's logic. The walls we see, physical or emotional, are not always as solid as they appear. In the quantum world, walls don't mean never. They mean unlikely. And in a sea of unlikely things, the improbable becomes inevitable. So you lie there now, not as a solid object, but as a cloud of potential, as a being in which countless quantum leaps are taking place. The barriers inside you are being crossed without effort, without damage, without sound. You are not defying nature. You are aligned with it. Tunneling reminds you that progress can be silent. Transformation can be small. And yet, its impact can light a star. So when you face a wall, when life feels sealed off or static, perhaps you can think of the particle, of its patient, rhythmic hum, of its refusal to obey only what's obvious, and of the beautiful truth that some of the most important journeys happen in silence. You begin to drift now, not just toward sleep, but toward a new sense of softness, You are surrounded by improbable grace. It moves within you. It fuels your breath, and it lights the sky above you. Tunneling is not rare. It is not exotic. It is essential. And as you settle even deeper, you begin to feel something new. A question, soft and shimmering, rises through your thoughts. If tunneling lets particles pass through barriers they shouldn't cross, then what might it mean for information, for memory, for connection? Can something deeper than particles tunnel too? You rest a little deeper tonight. Sleep clings to your body like a warm fog, and somewhere beneath your dreams, the world continues its quiet unfolding. Atoms hold their breath, fields ripple unseen, and deep inside certain elements, something old is letting go. You may not feel it, but at this very moment, tiny hearts are breaking open, not with noise or violence, but with a whisper. This is radioactivity, a word that once sounded dangerous, but here, in the hush of night, it softens into something older, something more natural. Radioactivity is not a threat. It is a memory. It is time, unraveling itself in the secret places of matter. You see, not all atoms are content. Some are restless, holding more energy than they need, tightly packed in their cores, as if burdened by history. Their nuclei, dense and trembling, reach a point when they must release. They let go, not all at once, not in chaos, but in deeply timed moments, so precise, so patient, you could miss them in a lifetime. These atoms decay, and in that decay, they change, transform. They become something new. It is not unlike falling asleep, letting go of the day, drifting into a quieter version of yourself. Some isotopes decay in milliseconds. Some take billions of years. Uranium, for example, has been slowly unraveling since the birth of the Earth. Its radioactivity, a kind of ticking in the clockwork of deep time. Imagine that for a moment. A single atom, older than the oceans, still holding energy from a world long gone, still glowing gently in the silence beneath your feet. This is not magic. It is physics. The nucleus, that tiny, heavy heart at the center of an atom, is made of protons and neutrons bound together by the strong nuclear force. It's a force more powerful than anything else you know. But even the strongest bonds can become unstable when too many protons jostle together, or when the balance is just slightly off. The atom trembles, and in that trembling, a decision is made. Release something, change form. That release, whether it's a burst of energy, a stream of particles, or a slow shiver of transformation, is radioactivity. It doesn't feel violent here in the quiet. It feels inevitable, like autumn leaves falling, like stars dying with light. You might think of radioactivity as decay, but it's more honest to call it transition. The old giving way to the new, the past making room for the future. And it has shaped everything you are. Long ago, in the molten heart of Earth, radioactive elements warmed the core. Their slow decay became heat, and that heat churned the planet's insides. It drove the movement of continents. It birthed volcanoes. It made magnetic fields that protect your sky. It gave Earth a heart that still pulses with quiet fire. Without radioactive decay, our world might have cooled too quickly, might have hardened into stillness, might have never grown life at all. Even now, your body carries traces of it. Potassium 40, a naturally radioactive isotope, lives quietly in your muscles, whispering its ancient release. You are, in the smallest way, a flicker of radioactive light. And in stars, those giant furnaces of fusion, radioactivity plays another role. When the star's core can no longer fuse new elements, it collapses. And in its death, the heaviest elements, uranium, thorium, gold, are born. Then those elements journey across space, hitching rides on meteors, dusting planets, settling into rocks, and someday into bones. The gold on your ring, the trace uranium beneath your feet, the calcium in your teeth, all may carry the signature of radioactive dreams. Decay is not something to fear. It is part of a larger rhythm, like waves smoothing stones, like fire giving way to fertile ash, like the end of one breath becoming the beginning of another. But there is a strange beauty to it, isn't there? That something so seemingly destructive is also the keeper of time. Radioactive decay happens in patterns, half-lives, we call them, the time it takes for half a substance to change. Not all at once, but statistically, predictably. One atom may decay in a moment. Another may wait 1,000,000 years. But over time, the pattern emerges, steady, soft, certain. It's as if each atom dreams in its own tempo. And when the dream ends, the light changes. Even some of the oldest tools we have, carbon dating, for example, depend on this. We measure the radioactive echo of ancient life to understand how long ago it lived. Fossils, charred wood, buried bones, all carry this quiet clock. You may not hear it ticking, but it's there, a metronome of matter, guiding time forward. So now, as you breathe into sleep, perhaps you can feel just how alive even the dead things are. A rock may seem still, but within it, atoms are shifting, particles are leaping, transformations are blooming in slow, glowing silence. And somewhere on a distant planet, the same is happening. Because this isn't just Earth's story. It's the story of matter, the story of stars collapsing, of elements reshaping, of possibility persisting through time. And in your dreaming mind, you might begin to wonder if atoms can decay across millions of years, if stars can die and give birth to gold, then what else is possible? What else might change? Not with force, but with slow, radiant patience? Maybe even the parts of yourself you thought were fixed. The old fears, the worn stories, the walls you've carried too long. Perhaps they, too, are waiting for their half-life, for their own quiet decay, not in pain, but in release, not in ruin, but in radiant transformation. Radioactivity is a lesson written in matter itself, that letting go is sometimes the most natural thing in the universe. You drift a little deeper now, cradled by the warm hum of ancient atoms, their glow, their patience, Their quiet unraveling wraps around you like a dream. And as the night deepens, a new thought begins to rise. A question, gentle and shimmering. If an atom can decay into something new, can two atoms ever stay connected, no matter how far they drift apart? There is something beautiful about a contradiction that still works. You open your mind like a window in the dark, and into it flows the warmth of stars, their light older than your memories, their glow crossing the impossible to reach you. You might not think about stars while you sleep, but they are there, humming in the backdrop of your breath, woven into the chemistry of your blood. You are not separate from them. You are stardust, rearranged. And yet, the question lingers in the quiet. How do they burn? How do stars, those distant fires hung in the velvet dark, sustain themselves for billions of years? How do they glow so endlessly, their hearts alight with energy, in defiance of gravity's hunger? The answer, curiously, is a little impossible. At least, it should be. You see, deep in the core of a star, there is a problem, a cosmic standoff. To create light, to keep burning, a star must fuse hydrogen atoms together, smashing them so tightly that they become something new, helium, then heavier elements, a chain of creation that builds the universe. But hydrogen atoms don't want to touch. Their positively charged protons repel each other like two magnets flipped the wrong way. The force that holds them apart is strong, and under normal rules, they should never get close enough to fuse. And yet, they do. Not often, not easily, but just enough. Enough to shine. Enough to survive. Enough to light the galaxies. This mystery puzzled physicists for decades. How could something so unlikely happen so consistently? How could stars rely on something that, by all classical reasoning, shouldn't happen at all? The answer lives in the strange place you've already begun to know, the quantum world, and in particular, the phenomenon called quantum tunneling. You've met it before. Particles slipping through barriers they have no business crossing. A dance beneath walls. A ghostly whisper of probability becoming reality. In the star's core, this dance is everything. Temperatures soar to millions of degrees. Particles zip around at unimaginable speeds, but still not fast enough to regularly overcome the electrical repulsion between protons. They need help, and that help comes from the quantum nature of reality. You see, in the quantum world, a particle is not just a point, it's also a wave, a spread out field of probability, a soft echo of all the places it could be. When two protons approach each other, their wave functions blur, and in that blurred space, there is a tiny but very real chance that one will tunnel through the barrier. It's as if the universe allows them to cheat, not always, but often enough to keep burning, not by force, but by possibility. And this tiny loophole, this quiet defiance of classical logic, is what allows the stars to shine. Tunneling is rare. Most collisions fail. But the sheer number of attempts, the endless crashing of particles in the furnace of stellar cores, means that eventually, miraculously, enough of them slip through, enough fusion, enough fire, enough light. And so the star lives on. You might think of it this way. Imagine a mountain with a smooth, impossible wall. A ball rolls toward it, not nearly fast enough to climb. Classically, it bounces back every time. But quantumly, there is a tiny, miraculous chance the ball appears on the other side. Not because it broke the wall, but because, in the quantum realm, walls are not as solid as they seem. That is tunneling. That is how the star survives. It is a system built on the edge of the impossible. And it's not just stars. Nuclear fusion, the dream of clean energy on Earth, hopes to harness the same process, to recreate the conditions of a sun in machines small enough to hold in laboratories. We're still learning, still chasing the precise rhythm that nature plays effortlessly in the heart of stars. And all of this, the light in your sky, the warmth on your skin, the gold in your veins, began with particles slipping through barriers they should not have passed. It is, perhaps, a comforting thought that the most fundamental light in the universe comes not from certainty, but from possibility, from the quiet power of something improbable happening just often enough to make everything else possible. So when you doubt, when the weight of logic says you can't, remember this: the stars, in all their brilliance, exist because of a loophole, because the universe leaves room for the unlikely, because nature, in her deepest poetry, relies not only on what should be, but what might be, and in that tiny space of might, a whole cosmos is born. You turn in your bed, bathed in the gentle shadow of moonlight, and perhaps now you feel that connection more deeply. You are not just looking at the stars. You are made of them, formed in their fire, written by their quantum flickers. Inside you, in your atoms, there are echoes of ancient fusion, of tunneling moments that sparked suns, that made elements, that wove galaxies. You are a story told by the improbable. And perhaps, if tunneling keeps stars alive, it also keeps hope alive. The hope that even what feels impossible can happen in its own quiet rhythm. But there is something else, something deeper still, that waits in this journey. Because if tunneling can make a star, if particles can slip through space and reappear, then what happens when two particles become connected across vast distances? What happens when their fates become one thread, no matter how far they are pulled apart? You breathe into the next question, soft, shimmering, strange. You feel the sun on your skin, perhaps not now, in the hush of night, but your body remembers it, the warmth, the golden weight of it, a quiet radiance that seems simple. But what you feel is anything but simple. The sun shines because something strange is happening inside it, something delicate, unlikely, and constant. It is not just burning, it is tunneling. Let your thoughts drift upward, beyond rooftops, past drifting clouds, into the blue quiet of the upper sky, higher still, until the blue fades into black and the sun floats before you like a flame suspended in emptiness. You've seen it as a bright circle, but what it truly is a quantum furnace. Inside, at its core, temperatures soar to over 15 million degrees. It's hard to imagine. Even the word hot becomes meaningless here. At such temperatures, atoms break into pieces, their electrons stripped away, leaving bare protons rushing through a sea of nuclear fire. This place is impossibly dense. The matter here is crushed tighter than in any place on Earth. Protons are packed so close they barely have room to breathe, if particles could breathe at all. And still, they resist. Even with that heat and pressure, something stands in the way. A wall made not of stone, but of electric repulsion. Protons don't like to touch. They push each other away with invisible arms of force. This is the Coulomb barrier, a barrier built by nature itself, and it is tall and strong and absolute in the classical world. But deep in the heart of the sun, classical rules begin to melt, and in their place, the quantum world quietly takes over. Each proton is not just a point, but a wave, a soft, spread out haze of possibility. Their positions are not fixed, their paths not certain. They live in a world of chances. When two of these proton waves get close, their shapes begin to overlap. The barrier between them, that electric repulsion, starts to blur. And in that blur, a miracle can happen. One wave slips through the barrier, not over it, through it. A tunnel opens where no tunnel should exist. Not a tunnel made of space, but of mathematics, of possibility. And through it, a proton appears on the other side, closer than it had any right to be, close enough to touch, close enough to fuse. This is quantum tunneling. And in the core of the sun, it is not rare, it is essential. Without it, the sun could not shine, because without tunneling, the protons would never fuse. This is what lights your world. It is easy to imagine the sun as something violent, a storm, a blaze, an eruption. But in truth, it is a whisper of probabilities. It burns not with rage, but with rhythm, with tiny particles slipping through impossible walls, again and again, quietly making light. And that light, that very light, reaches you. It takes time. Photons created at the sun's core bounce for thousands of years before escaping the dense solar layers. They zigzag, scatter, and wait. And then, finally, they burst free, racing outward at the speed of light. 8 minutes later, they reach your face, and you, standing on Earth, feel the warmth of an ancient tunneling event that happened before any memory you carry. This is the poetry of physics. That something so small, so unlikely, so hidden, can become the force that feeds life, grows forests, warms oceans, and fuels your body. You are not just warmed by the sun. You are kept alive by a quantum miracle. Tunneling doesn't just happen once. It happens constantly, millions of times a second in every star. Each success is rare, but the universe is patient. It waits for the improbable and builds its kingdoms from that patience. And it is not just the sun. Every star, from the faintest ember to the grandest giant, relies on this same trick, this same quiet tunnel. They live on the edge of what should be impossible. And yet, they thrive. There is something deeply comforting in that nature doesn't always play by hard rules, that it leaves room for softness, for uncertainty, for passageways that open in the most unexpected places. Perhaps you felt it in your own life when a door seemed closed, but something let you pass anyway. When logic said no, but something deeper whispered yes. The sun is your teacher then. Its fire reminds you that not all walls are forever. Some are illusions waiting to be passed through. But the story doesn't end here, because tunneling in the sun doesn't just create light, it creates something else too. Something ghostly, something strange, something that passes through your body every second, unseen, unfelt, but real. They are called neutrinos, born from the same fusion reactions that make sunlight. Neutrinos are tiny, nearly massless particles that barely interact with matter at all. They are tunneling's silent children, and they are coming. Even now, even as you lie still, billions of them are streaming through you, from the sun, from distant stars, from the deep past of the cosmos. They pass through walls, through your pillow, through your bones. You do not stop them. Nothing does. They are messengers from the heart of stars, tiny whispers of energy that carry the story of fusion across space. And in the next chapter, as you lie quieter still, you will follow them. You will ride the neutrino's path through stone, through skin, through space itself. And perhaps then you'll understand why something so small can feel so infinite. You're quiet now, breath slow, mind loose and drifting, still held in the warmth of stars and tunneling light, still wondering how something so gentle, a proton's whisper, a wave's blur, can hold the weight of the cosmos. But the deeper you drift, the more you begin to feel it. This universe is not built on certainty. It is built on maybe. And maybe isn't a weakness. Maybe is the space in which all things begin. In the world you know, by daylight, things seem simple. A coin flips heads or tails. A door is open or shut. You are here or you are not. But in the quantum world, reality plays by different rules. A coin spins and stays suspended. A door flickers between states. A particle is here and not here until you look. This isn't poetry. It's probability. And probability, strangely enough, is math. But not the hard-edged math of rulers and angles. This is soft math, dreaming math, the mathematics of maybe. Let your mind drift there. Imagine you are watching a single particle, tiny, quiet, floating in a box. You want to know where it is. You want to point and say, there, but you can't. Not exactly. Instead, what you get is a map of maybes, a curve, a wave, a delicate shape, stretching across space. This wave doesn't tell you where the particle is, but where it might be, and how likely each location is. This wave is called the wave function, and it is one of the most important ideas in quantum physics. It's like a probability cloud wrapping around the particle, telling you, here's a strong maybe, there's a weaker one, and beyond that, it fades into almost never. The particle itself is real, but its position its momentum, its very being. Those things shimmer in uncertainty until you ask the question. And here's the strange part. Once you do ask, once you look, once you measure, the maybe collapses. The cloud vanishes, and the particle says, I am here, but only because you asked. Before that, it was all possibilities. This moment, this strange shift from cloud to clarity, is called wave function collapse. It is not a physical explosion, but a soft narrowing of truth. A choice is made, not by the particle, but by your gaze. It is as though reality waits to be witnessed, and then it chooses. Some physicists have tried to explain it away. Some say the particle was always there. We just didn't know. But quantum experiments say otherwise. Time and again, particles behave not as hidden marbles, but as shimmering, overlapping maybes. So what does that mean? It means the universe doesn't run on yes and no. It runs on shades of perhaps. Even the most precise predictions are written as likelihoods. A 60% chance it's here. A 30% chance it's there. A tiny chance it's elsewhere. And over time, as you let this idea settle in, you realize this isn't a flaw. This is the design. The mathematics of maybe is not an excuse for not knowing. It's a deeper kind of knowing, a map of the possible. And it works. Quantum probability doesn't just predict behavior. It explains everything from how atoms form, to why the sun shines, to how your very thoughts arise from particles that do not behave like little dots, but like waves of chance. Even chemistry, the way atoms bond and share, depends on probability clouds. Electrons don't orbit like planets. They blur, they hum, they wrap around nuclei like mist. Each bond is a balance of maybes agreeing to hold hands. So the next time you think of math, don't think only of equations carved in stone. Think of shimmering curves, soft probabilities, fields of gentle suggestion. This is the math of the quantum world. The math that says, I can't promise you where, but I can whisper how likely. And there's something beautiful about that, because it reflects how much of life is lived, not in absolutes, but in potentials. You don't always know what tomorrow holds. You live in the maybe. And still, you go on. You choose. You love. You leap. Just like a particle, drifting through its field of choices, waiting for a moment of certainty. And sometimes, maybe is enough. Enough to build a world. Enough to ignite a star. Enough to begin. Now, let yourself go even deeper. Imagine the wave function not as one shape, but as many, overlapping, interacting. Because particles are not alone. They influence each other. One measurement affects another. One maybe shifts the shape of another's maybe. And from this tangle of chance comes meaning. In this moment, you lie still, your body composed of atoms, those atoms of nuclei and electrons, and those particles not fixed, but floating, all of them, still governed by this math of uncertainty, still dancing on a field of probabilities, still saying, I might be here, I might be there, I might be both, and yet somehow you are you. A being, coherent and warm, resting in bed, held together by math that never promised anything at all. And now, as the air grows even softer, you begin to see the next step. Because this may be math, doesn't just apply to where things are, it applies to what they are. A particle might not just be in multiple places, it might be in multiple states, alive in superpositions, wearing more than one mask, holding more than one truth at once. A coin spinning through the dark, both heads and tails, until the final fall. This, too, is real, and this, too, is next. Close your eyes. Let that thought settle like dew on the field of your mind. Somewhere in the quantum world, a particle waits, not to choose a state, but to exist in all of them. And it will, until someone looks. Your body lies soft and quiet, but within it, a secret world is alive. Close your eyes and feel it. Not just the rhythm of your breathing, not just the slow thump of your heart. Feel deeper, beneath muscle and blood, beneath bone and memory. Something small and bright is always moving. This is the world of particles, the world of electrons and protons, of tunneling and uncertainty, of soft boundaries and invisible rules. And it's happening in you right now. You may think of quantum tunneling as something distant, something that belongs to stars, to radioactive rocks, to labs full of blinking machines and silent equations. But tunneling isn't far away. It's not even rare. It happens inside your body all the time. Without it, you wouldn't be here. You wouldn't think, breathe, dream. You wouldn't remember, or sleep, or be. Let yourself drift gently toward this hidden truth. Let your thoughts become smaller, lighter, like leaves on water. Now, imagine one of your cells. Just one. Inside that cell, hundreds of processes are at work. Proteins folding, ions flowing, enzymes snapping into place with elegant precision. But one of the most essential of these processes, the very heartbeat of cellular energy, depends on something impossible. Particles tunneling through barriers they should never pass. Inside your cells, there are tiny powerhouses called mitochondria. You've heard the name before, a whisper from a biology book or a classroom long ago. These mitochondria are like miniature engines, fueling your life with each quiet spark. And at the core of their work is something called the electron transport chain. Don't let the name weigh you down. It's just a series of handoffs, like a torch passed along runners in the dark. Electrons, small and swift, jump from one molecule to the next, releasing energy along the way. But sometimes, the jump is too far. The electron should stop. The gap is too wide. The hill is too steep. The barrier is too high. And yet, the electron appears on the other side. Not by force, not by magic, but by quantum tunneling. It behaves as if it doesn't care about the wall. As if, instead of smashing through it, it slips beneath it, like a dream sliding through thought. And when it arrives, energy is released. A tiny flame in the quiet of your cells, repeated millions, billions of times, every second of your life. This tunneling fuels your body's most basic needs. It powers your muscles. It keeps your brain alight. It helps turn the food you eat into motion and thought. Without it, your cells would shut down, your breath would pause, your dreams would fade, all because a tiny particle does something it shouldn't and does it anyway. And this quiet defiance of the rules is not rare, it's essential. Even in the act of DNA repair, quantum tunneling may play a role, helping enzymes reshape broken strands, guiding tiny protons across impossible gaps, preserving the story of who you are. Every moment, your body walks the line between the possible and the probable, and quantum mechanics walks with you. There's something deeply humbling in that, isn't there? To think that your heartbeat, your thoughts, your feelings are not just guided by biology, but by a math that whispers in maybes, by particles that behave like waves, by tunneling paths carved through pure possibility. You are not separate from the strangeness of physics. You are the strangeness of physics, wrapped in skin, bathed in breath, thinking itself into awareness. And the barriers within you, those molecular hills and walls, are crossed with quiet grace every single moment. There is beauty in that, because the universe could have been rigid. It could have followed only the strictest of rules. Walls could have stayed walls. Barriers could have been final. But instead, the universe allows for softness. It allows for exceptions. It allows for tunneling. And that softness allows you to exist. Now, let this idea settle deeper into your chest. You may think of barriers in your life, not molecular, but emotional, mental, personal. Things that feel too high to climb, too thick to see through, too strong to pass. But maybe, just maybe, your very nature reminds you that not all walls are walls. Some things are crossed not by force, but by quiet persistence, by showing up again and again, by becoming small enough, still enough, to slip through unseen, like an electron in a cell, like light through skin, like thought through doubt. Tunneling isn't loud. It doesn't announce itself. It just happens, against the odds, beneath the surface, until something new is born. And so, tonight, as you lie still and warm, you can take comfort in the idea that your body already knows how to move through the impossible. You are made of particles that do not stay where they're told. You are built from matter that believes in maybe. You are living proof that even barriers can be beautiful if we learn to dance beneath them. And tomorrow, when you face a wall, outer or inner, remember that soft things can pass through, not by force, but by nature. You don't need to break everything. You just need to believe that what seems impossible may already be happening inside you. And as this thought fades, like breath, into silence, you begin to wonder, if tunneling keeps your body alive, what might it mean for your mind? You are halfway between worlds now, half dream, half thought. Your body still, your mind floating like a feather on the breath of sleep. This is the space where possibility begins, where things don't have to be only one thing, where thoughts stretch into stories and stories fold into riddles. Tonight, you will meet a cat, but not a cat you can pet, not one you can see, not one that purrs or yawns or curls at your feet, No, this cat lives in a question. It's called Schrodinger's cat, and it's one of the most famous creatures never to walk the earth. It lives inside a box, and the box is closed. That's important, because what happens inside the box, or rather, what doesn't happen, is the heart of something very strange. But first, let's take a step back. We've wandered through quantum fields. We've watched particles tunnel through barriers, slip through walls, exist as both wave and thing. Now we ask, what does it mean for something to be more than one thing at once? Can a particle be both here and there? Both moving and still? Both real and potential? Quantum physics says yes. And the cat, that sleepy, invisible cat, is here to help us feel just how strange that yes can be. Here's the thought experiment. Imagine a closed box. Inside, a cat. Also inside, a tiny bit of radioactive material. Just enough that, in the next minute, there's a 50 by 50 chance one atom will decay. If it decays, a detector triggers a mechanism. It releases poison, and the cat dies. If it doesn't decay, the cat lives. But here's the twist. In the quantum world, until the box is opened, the atom exists in a superposition, both decayed and not decayed. So what about the cat? By the logic of quantum mechanics, the cat, too, must exist in superposition, both dead and alive. Not either, but both. Paradox. A riddle. A whisper that reality may not be as real as we think. And now, as you rest, you may feel something familiar in this strangeness. You, too, exist in superposition. Not physically, perhaps, but in your mind. You are awake, and yet you drift. You're thinking, and yet you are letting go. Between sleep and waking, you are the cat. You are in the box, both here and not here, both listening and dreaming, both whole and gently unraveling. This place, this state between, mirrors the quantum world. And the quantum world, despite its equations and particles, is not so distant after all. The cat is not real, of course. No animals are harmed in quantum thought. But the lesson it teaches is deeply real. Because in the quantum realm, particles don't make a single choice until they are observed, until the box is opened, until the question is asked. This is what we call superposition. It's not indecision. It's not confusion. It's openness. A willingness to hold all possibilities at once. Electrons do it. Photons do it. Even whole molecules, under the right conditions, have been placed into this uncertain state. It is not that the universe doesn't know. It's that the universe waits until the act of looking collapses the maybes into a single yes. And so, too, does the cat. And so, too, do you. You are filled with paths you did not take, thoughts not spoken, dreams not followed yet. And just like a particle, you hold them all inside you until a moment comes when one becomes real. You live in superposition, a life of infinite threads woven into a single experience. Your future, every possible version of it, exists like a cat in a box, not yet opened, not yet chosen. This is not frightening. This is freedom. It means you are never trapped in only one story. You are always on the edge of another version, another path, another unfolding. Quantum physics invites you to imagine a world where the line between possibility and reality is not hard and fixed, but soft and shifting. The universe is not built like a machine. It's built like a wave, a ripple, a question. And questions can live without immediate answers. So what happens when we open the box? What happens when we observe? When we choose? When we draw the line? One possibility becomes real. The rest dissolve. But while they existed, they mattered. They shaped the whole. Even the unchosen paths leave a trace, like footsteps in the fog. That's the strange magic of quantum thinking. It doesn't just show us how particles move. It shows us how truth can be layered, how knowing something can change the thing itself. And so, you lie there, eyes soft, mind open, both waking and drifting, like a thought half spoken. You, like the cat, are suspended in potential. And maybe that's what makes this moment so special. This liminal space, this flickering in between, is not a failure of clarity. It's the birthplace of all things. All action begins in uncertainty. All discovery begins with maybe. Even love, even wonder, even science. You begin to understand now why physicists and poets often walk the same line. Because quantum mechanics, in all its logic and mathematics, feels a little like dreaming. It lets the universe be unsure, and in that uncertainty, it allows life to emerge. From the atom to the star to you. Now, the cat waits. The box remains closed, and you too remain not one thing, but many. Your breath is a gentle wave. Your thoughts, like particles, dance just beneath the surface. And somewhere in your chest, a quiet question stirs. If the universe chooses when we look, what happens to the paths we never see? You lie still beneath the ceiling of stars. The day is gone. The world has hushed. And in this silence, a strange and gentle question floats into the air around you. Does the universe watch itself? You have heard before that particles behave like whispers, subtle and uncertain, until they are watched. That the very act of observation changes what is real. That when you look, something solidifies, something chooses. But what does it mean? To watch? Close your eyes. Not to sleep just yet, but to feel more deeply. Within your own mind, a theater flickers, memories, images, drifting thoughts. You are aware of them, and aware of yourself being aware, a kind of quiet observation. If you can observe yourself, might the universe be doing the same? In the world of quantum physics, the observer plays a central role. It is said that until something is measured, it exists as a spread of possibilities, a cloud of maybes. The electron is not here or there, but both and neither. Only when you observe, when you measure, does the cloud collapse into one outcome. This is called wave function collapse, and it makes you wonder, without observation, is anything truly real? But then another thought arises. What counts as an observer? Is it only a person? Only a scientist with a machine? Only a conscious mind? Or could anything that interacts become the watcher? Some physicists think so. They suggest that every time a particle touches another, every time a photon nudges an atom, every time one thing influences another, a kind of watching happens. Not the kind that thinks or sees, but the kind that records. A mark is left. A choice is made. Reality leans one way instead of another. In this view, you don't need eyes. You don't need minds. Just touch. Just connection. Just interaction. And that's a kind of beauty, isn't it? The universe doesn't wait to be seen. It simply sees itself in every meeting, in every motion, in every quiet unfolding of one thing into another. And yet, there are still more mysteries. Some say that watching doesn't collapse reality, it splits it. This is the strange vision of the many worlds interpretation. Here, when a particle could go left or right, it doesn't choose. It goes both ways, and the universe branches. One version of reality for each possibility. In one world, the particle turns left. In another, it turns right. In both, the universe continues, unaware of the others, but just as real. When you open your eyes, you aren't collapsing reality. You are joining the path. Your act of noticing doesn't erase the maybes. It walks into one of them. And so the universe is not a single unfolding, but an endless blooming of what could be. A garden of shadowed mirrors, each one holding a reflection of what might have happened. If this is true, then watching doesn't create the world. It selects it. You are a traveler, gliding softly between branches of maybe. And yet, even this is not the final word. Some scientists offer a simpler idea that watching isn't magic. It's just thermodynamics, just entropy, just the spreading of information. They say that when a system becomes large enough, complex enough, entangled enough with its environment, it settles into reality. Not because someone looks, but because it must. Because patterns emerge. Because chaos demands structure. This is called decoherence. Imagine a spinning coin, not yet heads, not yet tails. It flips in the air, but when it touches the ground, it must choose. In this view, the ground is the world, and the spin doesn't collapse because you looked. It collapses because it lands. So maybe the universe doesn't need an eye or a mind. It just needs the weight of itself, stillness, touch, presence. And so, gently, you return to the question, not with a demand for answers, but with an openness to wonder. Does the universe watch itself? If observation means awareness, then maybe yes. Maybe the universe is aware of itself through you, through others, through stars that explode and molecules that bind, through each unfolding pattern of complexity. And if observation means interaction, then yes, again, because everything touches something. Every moment leaves a trace. Nothing is alone. And if observation means selection, the choosing of a path from many, then your very being is a kind of watching, kind of belonging. You are one thread among countless others, a ripple in the fabric of all possible futures. And if watching is none of these things, if the universe simply becomes without eyes, without mind, then maybe that too is beautiful, because then watching is not required. Existence flows on its own, and you resting here in your bed are part of that flow. So many ways to be, so many ways to become real, so many meanings of watching. And maybe, just maybe, it's not a question of whether the universe watches, but how softly it does so. Through wind, through rhythm, through gravity, through thought. Your breath slows. You feel the quiet pulse of your own awareness, nestled in the curve of something vast, not separate, not above, but woven in. You are not outside the watching. You are the watching, and you are the watched. Now, somewhere deep within, another question begins to shimmer. If life is shaped by particles that tunnel, that leap, that choose impossibility to become possible, then what does that mean for life itself? You are made of matter, molecules, cells, bones, and breath. But underneath all that, under your skin, behind your heartbeat, something more subtle moves. Not just biology, not just chemistry, but something softer, stranger, something that dances on the very edge of what should be possible. Quantum rules, and life somehow listens to them. You take a breath. Invisible air slides into your lungs. Oxygen waits patiently, not knowing it will soon meet iron in your blood, hitch a ride, and feed your every living cell. But how did that oxygen know where to go? How do molecules in your body recognize each other, touch each other, change each other? It isn't just random motion. There's a quiet intelligence to it, a rhythm. And now scientists are beginning to whisper what once sounded impossible, that life itself may be quantum. Let's begin with a leaf. A quiet green leaf resting in the afternoon sun. Light lands upon it, not all at once, but in tiny bursts, photons. And when a photon touches the leaf, it is caught. Its energy, so delicate, so easy to lose, is passed inside. But here's the marvel. That energy doesn't take one path to its destination. It takes all paths. It spreads like a wave. It explores every route simultaneously, sampling the garden of possibility until it finds the most efficient way, as if the plant is thinking, as if it knows. But it isn't thinking. It's quantum coherence, a dance of probability. The same rule that guides an electron through a tunnel now guides light through a cell. And you begin to see. Tunneling isn't just something particles do. It's something life does. Now, look inward. In your nose. Yes, in the gentle hollow behind your eyes. There is another strange story. You've heard that smell is about shape, that scent molecules fit into receptors like keys into locks. But the key doesn't always fit the lock. Sometimes the shapes don't match. And yet, you still smell them. Why? Because some researchers believe that you don't just smell shape, you smell vibration. Tiny quantum vibrations, resonating like musical notes. And your nose might be listening, not to form, but to frequency. Imagine you are reading molecules the way you might listen to a violin string. Quantum tunneling may allow an electron to jump, not randomly, but only when the right frequency sings, only when the note is true. A molecule hums, and you know the scent of rain, or old books, or someone you love. This is not a metaphor. It may be real. It may be you, your body, using the quantum rules of resonance to sense the world. And it doesn't stop there. In your cells, enzymes fold and twist. They break bonds. They build new ones. But some of these transformations happen too fast, faster than classical physics should allow. It's as if the molecules leap across a barrier that shouldn't be crossable. Sound familiar? It's tunneling again. Your body, it seems, doesn't just tolerate quantum behavior. It depends on it. These enzymes may guide protons or electrons through forbidden walls. They don't wait for heat or chance. They glide through silently as if they know the shortcut. They dance beneath the surface of chemistry, a quiet leap between what is and what should not be. And now, perhaps the most mysterious idea of all. In your brain, among the countless firings and chemical signals, some scientists suggest quantum processes might also be at play. It's controversial. It's not proven, but it is whispered. Tiny structures called microtubules, scaffolds inside your neurons, might, just might, hold quantum coherence briefly. If true, your thoughts may ripple with probabilities, not random, but meaningful, as if awareness itself straddled both certainty and maybe. But don't worry, you are not a quantum computer. You are not a puzzle to decode. You are a living presence, woven with threads both classical and quantum. You exist on the edge, where certainty meets possibility, where biology meets physics, where reality shimmers, just for a moment, before becoming solid. And you realize, life is not a machine. It is a story told in whispers, where rules bend, and leaps occur, and outcomes are not always logical, but they are always beautiful. Even in photosynthesis, even in smell, even in enzymes, even, maybe, in thought, life dances with the improbable, and that improbability makes it thrive. You are here because tunneling happens, because energy finds its way, because the universe permits the unlikely. And isn't that what life is? A quiet defiance of odds, a soft rebellion against entropy, a bloom in the silence of space. Tonight, as your body rests, that bloom continues. Quantum rules whisper beneath your skin. They hold your molecules together. They guide your breaths. They light the stars. And they light you. And you begin to see the pattern. The story this whole journey has been telling. That the universe is not distant, not other, not cold. It is tender. It is curious. It is alive in you. And as you drift, a gentle question returns. If life depends on tunneling, on uncertainty, on leaping through walls, then what else might leap? What other kind of motion has no mass, no charge, but reaches across distance in an instant? What is this strange presence that seems to know no bounds? You're almost asleep now, but a word begins to form, something light, something quiet. Entanglement. You're standing before a wall, not made of bricks or stone, not something you can touch, but something that stops you, quietly, invisibly. You reach out, but it doesn't move. You press against it, but it holds. This is the way the world often works. A rule, a boundary that cannot be crossed. In classical physics, a particle too weak to climb a barrier stays behind it forever. It reflects, it rebounds, it gives up. But you know now, that's not always how nature behaves. At the smallest scales, the rules begin to whisper instead of shout, and the impossible begins to soften. You remember the particle facing its wall. It doesn't crash into it. It doesn't blast through. Instead, it lingers. It becomes a blur, a presence that spreads into the forbidden space. Its wave function, the soft mathematical shape of its possibility, drifts into the wall, fades slowly, and yet, on the other side, it might appear it doesn't break the rules. It bends around them. It listens to the quiet loopholes in the laws and simply arrives, tunneling, silent passing through something that should be solid. Not every time, not always, but enough to matter, enough to shape reality, enough to let stars burn and leaves grow and enzymes work and atoms move, and maybe enough to show you something about yourself. You face walls too, not of concrete, but of fear or time or memory. You know the feeling of limits. You've stood at the edge of something you could not cross. A decision, a sorrow, a hope. But what if, somewhere in your mind, or heart, or body, a kind of tunneling was also at work? A slow, quiet process where you don't force your way through, but instead become possible on the other side, not with effort, but with presence, not with pushing, but with patience. Tunneling doesn't mean rushing. It means waiting inside your own uncertainty until the unlikely softens into real. And maybe this is how life moves forward, not by smashing through its limits, but by listening to them, by holding still until possibility opens a door where there was only wall. You are not separate from the particles. You are made of them. The same quiet dances are happening inside your body right now, inside your cells. Protons and electrons tunnel through barriers, so reactions can happen faster than heat or pressure would allow. Inside your senses, molecules may leap across tiny spaces, guided by vibration and resonance. Inside your breath, oxygen follows impossible paths, drawn through chemistry, shaped by quantum decisions. And all of this, without noise, without announcement, without certainty, just a gentle unfolding of what could be. Tunneling is not about destruction. It is about transition, about becoming, about trusting that even solid things are never truly solid, even walls, because no wall is absolute. No boundary is truly impassable, even the ones you carry inside. You may not be a particle, but you are possibility, and possibility moves in quiet ways. You don't always notice it. It doesn't look like change. It looks like waiting, like softness, like nothing at first. But then one day, you're on the other side of something you thought you'd never cross. You're there, and you don't even remember the moment you passed through. That's how tunneling feels. It is not loud. It is not clear. It is not always seen. But it is real, and it is happening in nature, in atoms, and in you. The universe does not only reward force, It also rewards stillness and patience and gentle trust in uncertainty. Because sometimes when you stop trying to break through, you begin to pass through, and it feels like grace, like a particle finding itself on the other side of the impossible. You rest now, your breathing slows, your mind drifts, but somewhere inside you, walls are softening, not because they are weak, but because you are learning how to move without resistance. This is tunneling too, not just physics, but a way of being. And as you float in this knowing, a new question begins to rise, like a ripple under still water, like a thought that hasn't formed words yet. If particles can appear on the other side of a wall, and if they can be entangled, connected across vast spaces instantly, then what is distance? What is space, really? And how can two things, separated by miles, or galaxies, or time, still know each other, still move together, still feel joined? You begin to feel that question more than understand it, and soon you will follow it into the quiet mystery of entanglement, where walls don't divide, and space is not what it seems. You are drifting now. The world around you is quieter, softer. The shapes of your day blur at the edges, melting into the stillness of night. And here, in the hush between thoughts, something beautiful is happening. Your body rests, but your mind begins its most intricate dance. Slow, unraveling, a gentle weaving, a process so mysterious, even science steps carefully around its edges. Sleep, it feels like nothing, like silence, like darkness. But inside you, everything is changing. Neurons pulse, cells repair, memories settle like falling snow. The day behind you dissolves. The day ahead begins to shimmer, not in detail, but in potential. You are tunneling again, not through space, not through walls, but through time itself. Each night, your mind steps back from the noise. It folds into itself. It lets go of the visible world and sinks into something deeper, not unconsciousness, but transition, quiet remodeling. Your brain shifts between rhythms. Delta waves rise. Dreams flicker into being. And in that dreaming, you begin to test what tomorrow might feel like. This, too, is a kind of quantum process. Soft, probabilistic, uncertain, like particles hovering in multiple states. Your sleeping mind explores what could be without deciding what must be. Possibility spreads across your inner sky. Sleep is not an ending. It's a crossing, a narrow, wordless tunnel from one version of yourself to the next. And every morning, you wake up on the other side. You think of particles again, of how they tunnel through walls, not by breaking them, but by becoming possibility on the far side of resistance. You are doing the same. Night after night, you step away from what was. You surrender. You soften. And in doing so, you make a space for change. Sleep is nature's gentlest portal. It doesn't demand. It invites. It welcomes you just as you are. Tired, uncertain, worn by thought. And it says, come lie down. Let everything you're holding become lighter. You don't have to carry your story right now. You don't have to solve the puzzle. You don't have to be awake to become, because sleep is a form of becoming. Inside you, enzymes find balance, toxins clear, neural pathways rewire with the quiet logic of dreams and deep time. This isn't just rest, it's transformation. And here's something beautiful. The same quantum tunneling that lets particles pass through walls also happens in your own body while you sleep, in your brain, within the enzymes that process thought. Tiny particles shift and jump in ways classical physics cannot explain. A proton here, an electron there, quietly tunneling through barriers so thoughts can flow, so chemistry can work with impossible efficiency. Even in rest, your biology is busy with miracles, and yet you feel still, peaceful, held. What you've learned on this journey isn't just about science. It's about softness, about how the universe moves, not only with force, but with patience, about how it allows for uncertainty and honors it. Even sleep is uncertain. You never know where your mind will go, what dreams may rise, what memories may surface, and yet you trust it. Night after night, you surrender and let the unknown carry you, like a particle trusting the other side of the wall without ever seeing it. This is your final chapter, but not an ending. Endings are illusions. Even in physics, nothing truly ends. It transforms, it tunnels, it becomes something else. The universe is always becoming. So are you. Your waking hours are full of effort, of decisions, of direction. But your sleeping hours are where the deepest shifts begin. Quietly, without your control. You are not falling asleep tonight. You are tunneling forward into healing, into memory, into new possibility. You may not see the shift, but it's happening. And tomorrow, when you rise, you will have crossed into something new. Not dramatically, but gently. And isn't that the way the universe prefers to move? Through gentle waves, through patient waiting, through silent crossings, where the improbable becomes real. You're part of that rhythm now. You've felt the edge of reality. You've held a particle in your imagination. You've walked with light, with waves, with uncertainty. You've passed through walls, into stars, into cells, into yourself. And now you rest. And that rest is not passive, it is sacred. You are returning to the soft center of everything you are. You breathe, the world holds you, and time begins to soften. Sleep is not a void, it is a cradle. It carries you to the next version of yourself without needing to explain how. The particle doesn't understand the wall. It simply finds itself on the other side. You don't need to understand every detail. You only need to trust that you are tunneling to toward healing, toward clarity, toward light. And as your thoughts fade, as your body releases its weight, you remember the universe is still moving, still becoming, still dreaming itself forward through you. Close your eyes now. Let go. There is nothing to solve. You are already on your way. The stars are still burning. The particles are still dancing. The soft fabric of reality is still humming around you. You are not behind. You are not late. You are not lost. You are in motion. Even in sleep, you are tunneling toward tomorrow. And now, your mind rests at the edge of wonder. If the stars whispered tonight, you listened. If the universe breathed, you breathed with it. Thank you for drifting with me into the quiet corners of science, where particles blur, time softens, and everything is possible. This is the Dreamy Physicist, where sleep is a journey and curiosity never closes its eyes. Until next time, rest well, dream gently, and remember, even in the stillness, you are moving through something beautiful. Good night.